My name is Ron Swanson. This is SJ23 Mr. Ahmed's Chemistry 2 Gas Law Project. The law I'm going to be doing today is Gay-Lussac's law. It states that P1 over T1 equals P2 over T2. Variable 1, which is P1 over T1, is the basketball at room temperature at 10 psi, or around that psi. Variable 2, the basketball after being in the freezer for 45 minutes. Needed materials include a pump. You can use like a regular Academy one like this with a needle, or a bicycle pump with a needle. This one comes with a gauge so you can see the psi that you are working with. You want an athletic ball. It doesn't matter what type it is. It could be a basketball, a football, as long as you can record the pressure out of it. And then lastly, we have a pressure gauge. The one on there doesn't read as finely as the one on here, so I'm going to be using this one to measure the pressure. My procedure is pumping up the basketball with the bicycle tire pump, and then recording the PSI, recording the temperature in here, which should be the same as outside because I don't have any AC at the moment, on it all. And then after recording all that data, placing the basketball without letting the pressure go down into the freezer for 45 minutes. After the timer has gone off, I will record the data, plug it all into the equation, and then find my percent error. And I'll be showing you all the steps along the way. Small hiccup in step 1, I burst the basketball because I inflated it too much. So I'm gonna be using a rugby ball instead. It's not gonna affect anything, it's just gonna be a different object. Step 1 is to insert the needle into the rugby ball and pump it up to around the ballpark of 10. After inflating the rugby ball, step 2 is to record the pressure in PSI. After measuring, P1 is around 11.4. P1 is around 11.4. T1, it is 26 degrees Celsius in my room right now, plus 273 is the conversion method to get 299 degrees Kelvin. After gathering all the variables, plug it into the equation. Step 3 is putting it in the refrigerator, which is 0 degrees Fahrenheit, which is negative 18 degrees Celsius. Converting that into Kelvin, it's 255 Kelvin. I plug that into the equation. I'm going to solve for the theoretical answer of what PSI should be after the refrigerator. Step 4 is to put the rugby ball into the refrigerator and leave it there for 45 minutes. While we wait for the rugby ball to freeze up, we cross multiply with all the variables. We get 299x equals 2,907. Divide both sides by 299, and that should be our ballpark when the rugby ball comes out of the fridge. 45 minutes and 1 shower later, our rugby ball should be good to go. Gonna grab it and measure the PSI. Measuring it, it's about 8.8. Now that we have all our variables and data, we plug them into a new formula, and now we can solve for the same and the percent error. We got our variables. They're a little bit different, and this is the equation to find percent error. Bigger minus smaller is the product under the bigger again, times 100 equals our percent error. The bigger being 0.0381 minus 0.0345 equals 0.0036. 0.0036 over 0.0381, which is the bigger of the two, equals 0.0944 times 100 equals 9.4% error, which I think is pretty good.